In this video, I'm super excited to talk about Dijkstra Algorithm. It's one of the most commonly used algorithms for finding out the shortest path between two nodes in a graph. So in this video, I'll be talking about what exactly is this concept of Dijkstra Algorithm, why this concept came into existence in this world, and how it can be applied to solve a given problem. So stick around to the end of this video because I'm going to discuss in detail about this algorithm. So let's say, for example, consider the scenario where you are living right now in Los Angeles, California. Now you want to go to New York City, New York. Now you have to find out the shortest path so that you can reach the place quickly, right? Nobody wants to take the long path. You want to take the shortest path so that you can reach the place from Los Angeles, California to New York City as quickly as possible. And sometimes you might take Uber, or sometimes you will drive by yourself, right? So any transportation method you take, they will actually calculate the shortest path. They have their own algorithm. If you take Uber, then they will have their own algorithms to find out the shortest path. But the basis for all these algorithms is Dijkstra Algorithm, because Dijkstra was the one who introduced the shortest path algorithm first and foremost. So let's talk about this amazing algorithm so that you'll be able to not only learn this concept, but also apply this concept in your day-to-day life so that you'll be able to find out the shortest path between two places, for example, or between two nodes in a graph. So let's get started. So today I'm going to talk about Dijkstra Algorithm. So Dijkstra Algorithm, there are two words, right? Dijkstra and algorithm. Now what does that mean? So Dijkstra is actually a human being in this world who introduced this algorithm, okay? One single human being. His full name is Dijkstra W. Dijkstra. Okay, this is the full name, and he is actually a computer scientist. Computer scientist. He is from Netherlands, so he's a Dutch computer scientist, okay? So he's a Dutch computer scientist because he's a Dutch computer scientist. He's from Netherlands, okay? And he had this idea to find out the shortest path, and so in the year 1956, he devised this algorithm, which is Dijkstra Algorithm. Now, what do you mean by algorithm? Algorithm means it's actually a step-by-step process to solve a problem. So what are the instructions or the sequence of steps which you have to follow? That is algorithm. So every problem will have an algorithm. So step by step, you will be able to execute this algorithm and solve that problem. So this is actually all about the basic concepts of Dijkstra Algorithm, the basic introduction. Now let's talk about where this Dijkstra Algorithm can be applied, right? So this algorithm can only be applied in a single source shortest path problem. Okay, so I mentioned single source. Okay, single source, what does that mean? So let's say you want to go from Los Angeles, California to New York City in New York. Now you have to choose either one of these as the starting source, right? So you are living right now in Los Angeles, so Los Angeles will be the starting vertex or the starting point. So you have the single source. You can choose both of these places. You have to choose a single source, and from there you are moving to what? New York City. So that's why it's a single source shortest path problem, and you're taking the shortest path, that's all. So if it's multiple sources, then you have to choose both. Los Angeles, California, as well as New York City, New York. So this is actually a single source shortest path problem. So let me explain you through a graph so that it will be clear for you, okay? So let me explain you the concept through a graph. So let me explain you the simple concept of Dijkstra Algorithm with a simple example, okay? So let's say this is a graph. So what do you mean by graph? Graph means it's a set of vertices and edges, right? So vertices should be there, or nodes should be there. So let's consider this for example, okay? This for example, let's say this is A, this is B, this is C, and this is D, and we have edges. So these lines are the edges, okay? So these edges can have directions, okay? So let's say this is the directions I'm giving. Now there are nodes, there are edges. Now this is actually a directed graph, right? This is a directed graph because there is direction and also cycle is formed. Let's say I again have this is given, okay? So this is a sample graph which I made for just illustrating this concept of Dijkstra algorithm so that you'll be able to understand it much better, okay? So where we can apply this concept of Dijkstra algorithm is if you want to find out the shortest path from A to C, right? A is the starting source, so you need to know the starting source, start, and the end. So this end can be anything, right? Anyway, you have to go through any A, B, C, and D and find out the shortest path to traverse all of these vertices. So this is nothing but node, right? And this is actually edge. This line is the edge, and this is the directions. Now you can apply this concept of Dijkstra algorithm, and this Dijkstra algorithm works in both directed graph and not directed graph. So directions are given here in this graph, so it can be applied for both directed and non-directed graphs, okay? And one more thing, what is the disadvantage of Dijkstra algorithm is that, you know, these edges will have something. What is that? These edges should have weights. So every graph will have weights. For example, this can be 9, this can be, these are weights, okay? It can be 7. So this number is the weight or the cost. Okay? Now, the drawback of this Dijkstra algorithm is that you cannot apply, maybe sometimes these weights can be having negative values. In that case, will this algorithm work? So if it's minus 11 here, okay, sometimes the algorithm works, but sometimes this algorithm doesn't work for negative values. So for negative weights, sometimes may or may not work for negative weights. So may or may not work for negative weights, okay, weights. So this is basically the drawback of this particular algorithm. This is a drawback, may or may not work for negative weights, because normally in real life scenario, you might be wondering, how can a distance be negative, right? How can it be minus 11? But actually, any problem can be translated into a problem in which there will be negative values. That's what happens in real large data sets. And so this distance for calculations can sometimes be taken negative for different purposes. And so there can be negative values in a graph, okay? You have to consider negative values also, but Dijkstra didn't consider that. Dijkstra didn't consider that negative values into account, so that's why it will only work for directed graphs and non-directed graphs, but it will sometimes work for negative values, but sometimes it will not. So we are not sure about it, but for all positive weights, it will work for all positive weights, okay? So this is the basic introduction about Dijkstra algorithm. Now let me talk about some of the example problems, and then you will be able to understand how this Dijkstra algorithm works. So this is the real life example which I've considered, okay? So this is actually the graph which I created. Now, this graph will have different places. So these are different places, okay? So this is Los Angeles, California. You will be able to see all the places here, okay? Los Angeles, Las Vegas, San Diego, San Francisco, Washington, D.C., and New York City. So you will have all of these cities, and you have distances. So these are the distances. These are random distances, okay? So now this is a graph having distances, having directions. Obviously, now we can apply the concept of Dijkstra algorithm because there is no negative values here, okay? So let's go ahead and do that. So the first step to apply this algorithm is to find out a starting point. And you, right now, you can choose any starting point you want. But I'm choosing Los Angeles as the starting point, okay? So this will be the starting vertex or the starting point. Now you have to go to all of these places in the shortest path, right? You have to visit all of these places in the shortest path now using this algorithm. Now, once you have identified this as the start vertex, so you are right now here, right? You're right now here. So let me circle this. You are right now here. Now from here, what you have to do is, so let me write it down. So start vertex should be there. Start vertex or the start node is what? LA. LA is the start vertex. Now from LA, you have to visit all of them. Now once you're in LA, this is start vertex. You have two ways, right? Two possibilities. You can go here or you can go here. Now what Dijkstra algorithm says is to find out the least value and go there. So from LA, 2 is less than 4, and so I'm going to here, okay? So I've reached LV. And that's what Dijkstra algorithm says. You find out the shortest path. But before even doing all of that, what you have to do, you have to find out the shortest path from LA, which is reachable to all the other places, okay, from LA, because once start vertex is confirmed, you have to find out the shortest path to other vertices. So let me say from LA, if I want to reach LV, Las Vegas, so I have to take 2 as the distance, right? So that's what I'm writing 2. The distance which I'm going to take, I'm going to write it here. So if I'm going to go to San Diego, then I have to take what? 4. So that's same distance. I'm writing it here. I'm using a different notation because everything revolves around this distance. Okay, this final distance will be the shortest distance. And so this is 2 right now, and this is 4. And what about from Los Angeles to San Francisco? In San Francisco, I can't go, right? I don't have a direct path. I have to go through LV, but I don't have a direct path. So if you don't have a direct path, it's infinity. And also I don't have a direct path to Washington, so infinity. I don't have a direct path to New York City, so I have infinity. So now you understood about the representation. So this is the first step, okay? Now everything is very simple. We use a concept of minimization or reduction, okay? This is a simple concept and you have to understand that. Relaxation, this concept is called relaxation. And what this concept talks about is you have to reduce, once you go from one node to another node, you have to reduce the distance to find out the shortest path, okay? So let's do it. This is done. Now the next step, once this is done, you have to find out, you are right now in LA, now you have to find out the shortest path from LA. There are 2 possibilities. You can go here or you can go here. Which is the shorter one? 2 is the shorter one. So you have to reach here, okay? So once you reach here, this is confirmed now. You have reached here, confirmed. And now, after reaching here, you have to find out which is the shortest path. You have 2 paths. You can go here or you can go here. But here it is 1. So what is already you have covered 2, right? Already you have covered 2. So 2 plus 1 would be 3. But here it's 4, right? If you go by here, it's 4. But if you go by here, it's 3. So what you have to do, you have to strike this off and you have to put 3 here. Because if you go by this route, you reach the distance in 3. So this is the shortest distance, right? So that's why. But if you take this path, okay, from here, if you take this San Francisco, then it will be 2 plus 7. It will be 9, right? So you have to cut this and put 9 here. Because 9 is the new distance, because from here, okay, from here, you have already reached 2. So 2 plus 7 will be 9. 2 plus 1 will be 3. And that's all. Now, from 9 and 3, which is the smaller one? 3 is obviously the smaller one. and you have to go there, okay? So you have reached here, and now you have to go here. And from here, how many directions are there? From San Diego, how many directions are there? It's only one direction. It goes only to Washington, D.C. And so we have to consider only Washington, D.C. What's the distance? It's 3. But already we have covered 3 distance now, okay? Now we have to add 3 and 3, which is 6. So let me add 6 will be, this infinity will be replaced by 6, because if you take this route, you will reach, if you take all of these routes, you will reach in 6 units of distance, okay? So that's why 6. Now, you have only, you cannot reach anything else, so you have to reach only Washington, D.C. Washington, D.C. is the shortest path now from here, San Diego, to Washington, D.C. Now, once you reach Washington, now you have to check what are the paths from Washington, D.C. You have 2 paths, San Francisco or New York City. Now, San Francisco is 2 and here is 5, but you already have taken 6. So 6 plus 2 is what? 8, but here it's 9. So you have to replace that 9 by 8. Because if you take this route, you will reach in 8 distance, not 9. 9 is the previous distance if you have taken that path. Okay? So if you take this, Washington to New York City, then it will be like 6 plus 5, which is 11. And so you have to cancel this and you have to like 11. Okay? Now once you've written here, now we have 8, 11, and 6, which is less. 6 is less, right? So we have to take from 6, already taken 6. So from 6, we have to take the path. Already we have chosen W. So from 8 and 11, which is shorter, 8 is shorter now. So we have to take 8. We have to go this direction. So San Francisco. And once we have reached San Francisco, now what is the path from San Francisco? Only one path to New York City, right? So what is 8 plus 1? 8 plus 1. How much distance? It's 9. So you have to cancel this and write 9 here. And there you go. You reached New York City. So New York also is reached. That's all. You've reached all the places. Now how did we follow? What is the path which we followed? It's quite simple, right? So we went like this, and then from there we went like this, and from here like this, and then here like this, and finally here like this. Now this 9 is the shortest distance, okay? So if you observe carefully, what is 2? 2 plus 1, 3. 3 plus 3, 6. 6 plus 2, 8. 8 plus 1 is 9. And 9 is the shortest distance from Los Angeles, California to New York. So this is how we find out the shortest distance by using Dijkstra Algorithm. So from each and every step, we try to reduce and find out the shortest path. So once we reach Las Vegas, we found out what are the paths are there from Las Vegas to other places. And from there, we found out the addition of these distances, right? And that we checked whether the addition of 2 and 1, which is 3, is less than 4, okay? So 3 is less than 4, so we have to cancel this and write 3 because that's the shortest path. So this is how you do that. Now we have to represent this in a format which is understandable so that I will be able to explain you step by step. What are the steps which I followed so that I'm canceling all of these, right? What are the different steps which I followed? I'll explain that now. So to represent whatever I've done in a tabular format, I am using this table, okay? This contains the selected vertex and also the places, different places to visit, okay? This is Las Vegas, then this is San Diego, San Francisco, Washington, D.C., and New York City, okay? Now, selected vertex in the beginning, what we selected is LA, so write LA here. Beginning LA, done. Now from LA, what are the distance which we have taken? Okay, distance. What is the distance we have calculated? We calculated distance as 2, right? From LA to LV. From LA to LV, which is 2. From LA to San Diego is 4. The initial distance. From LA to San Francisco, it's actually 9, right? So it's infinity because infinity was the beginning one. from LA, there is no direct path to San Francisco, so it's infinity, and there is no direct path from LA to W, so that is also infinity, and LA to New York City is also infinity. So this is the starting situation which we had. Now from this, the next vertex is what? The next, once we have selected LA, from LA, which is the shortest distance here? 2 is the shortest distance, right? So since 2 is the shortest distance, what is corresponding to 2 is LB. So write LB here. So Las Vegas, once you reach Las Vegas, okay, so from Las Vegas there are 2 paths, right? So we have to take the shortest path, and so from Las Vegas to San Francisco, we took the path which will be 9. So we can 2 plus 7 is 9, right? So from Las Vegas to San Francisco, it will be 2 plus 7, which is 9. Okay, and from Las Vegas to San Diego, it will be 2 plus 1, which is 3. So San Diego will be 3. Now all the other remains unchanged. So this path, there is no path. So this 2 we have already selected, and so if it's already selected, I'm circling because already we reached that state. Okay. Now out of this, which is the smallest value? Okay, so 2 is the smallest value, 3 is the smallest value out of all of these, so I'm choosing 3 now. Okay, so what is corresponding to 3 is San Diego. So San Diego is the next path. Now, once I reach San Diego, what is the path? I have only one choice. I have to go to Washington, right? And what is the distance? Which is 3. So already I taken 3 distance, so 3 plus 3 will be 6. So Washington will have 6. So I'm updating this Washington alone with 6, and all the other will remain unchanged. Alright, so this will be 3, this will be 2, and I've already selected all of these, I've already traversed them, so they are in this circle, okay? Now, which is the smallest? I've already chosen this thing, I've already gone through this. Now, which is small among these 3? 9, 6, and infinity, 6 is smaller. So I'm choosing 6 now. What is corresponding to 6? W. So W is Washington. So I'm going to choose Washington now. And once I reach Washington, right, I have how many paths? 2 paths. I can go to San Francisco or New York City. Now I want to choose the shortest path, but if I choose San Francisco, then it will be 6 plus 2, it will be 8. So San Francisco will be 8 now. So San Francisco will be 8. Because if I choose from W to San Francisco, there will be 8. If from W to New York City, it will be 6 plus 5, which is 11. So New York City will change to 11 now. All the other will remain unchanged. Alright? All the other will remain unchanged. Now, which is smaller among 8 and 11? 8 and 11, which is smaller? 8 is smaller. So you have to choose 8 now. So once you have chosen 8, what is corresponding to 8? San Francisco. So once you reach San Francisco, you have only one path, which is to New York City. So San Francisco, what is the value, which is 8? So 8 plus 1, which is 9. So New York City will change to 9 now. So New York City will be updated to 9, okay? And now all the other will remain unchanged. So these are already selected, this is already selected, already selected, already selected. Now what's left? What's left? Only 9 is left. So what is corresponding to 9, which is New York City? So New York City. That's all, done. So this is the path, shortest path from LA to Las Vegas. Let me write down the shortest path. So this is the shortest path from LA to Las Vegas, from Las Vegas to San Diego, San Diego to Washington, Washington to San Francisco, and San Francisco to New York City. So this is actually the shortest path. So let me write it down here for clarity. The shortest path will be corresponding to this one, LA to LB to San Diego to Washington to San Francisco to New York City. So this is what the the route which I will take if I want to go from Los Angeles, California to New York City, and this is the path which I follow. Now, what is the shortest distance? So this right here, bro, this is the shortest distance. Okay? So this is the shortest distance. The final distance which you obtain will be the shortest distance. So shortest distance are obviously shortest distance, or the cost will be equal to what? 9. There you go. So this is all about this concept of Dijkstra algorithm. It's quite simple, right? We modified the different distances in different steps, and so that process is relaxation. We did relaxation, and it is all based on how many nodes this is going out. So this LV has two directions, right? We can take two directions from LV, we can take outside two directions. And so from here we modify the two directions, right? So that's how you do that. So it all depends on, from Washington, you have also two directions. But for San Francisco, we had only one direction, so we modified only New York City alone in that case. So this is how you modify or updation, okay? Relaxation or updation. Updation of the process is being done, and this is actually a real life example. If you want to go from Los Angeles, California to New York City, how you do that? Instead of LA, LV, SF, NY, W, and SD, you can put anything here. You can plug in 1, 2, 3, 4, or A, B, C, D, or anything like that. But you understood the concept. That's all. This is all about this concept, and you have to actually illustrate with a table, and also with the help of this graph you'll be able to find out the solution very quickly. And this is also very useful for solving many problems in data structural algorithms in which you have to find out the shortest path. I hope you got to know about some valuable information about how you can find out the shortest path between two nodes in a graph. Thank you very much for watching this video.
Whenever your heart is broken, don't ever forget you're golden. I will find the light in your soul.